Right, so let's have a look at the Leaving Certificate Higher Level Maths Paper 1 for 2018, and let's have a look at question 7. So we have the time in days of practice it takes Jack to learn to type X words per minute can be modeled by the function t of x, which is equal to k times the log of 1 minus x over 80, where x is between 0 and 70, so the number of words per minute can only be between 0 and 70 inclusive. X is real, and k here is a constant. Based on the function t of x, Jack can learn to type 35 words per minute in 35.96 days. Write the function above in terms of k, and hence show that k is equal to minus 62.5, correct to one decimal place. So let's write down our function here. So we have t of x is equal to k times the log of 1 minus x over 80, and what we're going to do is just put in the information we're given. So we're told the words per minute is 35. So 35 is going to be our x, and t, our time, is going to be or t of x rather, is going to be 35.96. So we're going to put 35.96 here. We want to work out what k is. So inside here we got the log of 1 minus 35 over 80. Now let's just simplify this a little bit. We've got 35.96. We have k here. Now this is just going to become the log of 45 over 80, because we want to subtract 35 eightieths from 1, or 80 eightieths. So that's going to be 45 eightieths. So what I'm going to do now is just divide across by this thing here, log 45 over 80. So what I end up with here is 35.96 on the top, and underneath I end up with log of 45 over 80. And this is our k here. So I've written the function in terms of k first. Now all you've got to do then is work this out. This is all just calculator work here. So what you get when you work all of this out on the left hand side is k is equal to minus 62.5 to 1 decimal place, which is what we were asked, correct to 1 decimal place. And that's part A done. So let's have a look at part B. Find the number of words per minute that Jack can learn to type with 100 days of practice. Give your answer correct to the nearest whole number. So this time we've got to work out what x is, and we're given the time. So we're going to do 100 days of practice. So we have, again, we have our function, which is t of x is equal to, now we know what k is, minus 62.5, and then we have our log here. So we have our log of 1 minus x over 80. Now let's put in our information here that we're given. Well, we're given the time here, so we're given the time is 100 days. We've got our minus 62.5. We have our log 1 minus x over 80, and we've got to simplify this to try and get x on its own. We've only got one variable in here now, x, which is the words per minute that we've got to work out. So let's start. Let's see, what do we do first? Okay, so what I'm going to do first is divide across by minus 62.5, because that's multiplied here. So when I do that, I get minus 1.6. So on the right hand side I end up with log 1 minus x over 80. Now at this stage I've gone as far as I can with the log version of this equation. So what I'm going to do is convert it to index notation. So this is log to the base e here, if you like. So it's e to the power of minus 1.6 is equal to 1 minus x over 80. So I've just converted to index notation here. So e to the power of minus 1.6 will be what's in the bracket here. Now next thing I can do is subtract 1 from both sides. So I got e to the power of minus 1.6 minus 1 is equal to minus x over 80. Just brought this 1 over here, if you like. So the next thing I'm going to do is multiply across by minus 1. I want to get rid of this minus here. So multiply the left hand side by minus 1. This is what I'll get. Multiply this by minus 1, I'll get this minus here. Multiply this by minus 1, I'll get plus 1. Here I just end up with x over 80. Next thing I'm going to do is multiply across by 80, so that will give me x. Now, so in other words, I get 80 times 1 minus e to the power minus 1.6. Now, I'll just come up here now, so that will give me x. Then this is all numbers here. I can just stick into my calculator, and I get 63.84. Now, that's words per minute, by the way. So, what we were asked, give your answer correct to the nearest whole number. So to the nearest whole number, x is going to be equal to 64 to the nearest whole number. And that's it. This is our answer here, if you like. Okay, so let's have a look at part C then. Now I've done part C out already here, and I've drawn the graph here. I've done a couple of sections already, but let's just talk through it anyway. Part C here says complete the table below correct to the nearest whole number, and hence draw a graph of t of x between 0 and 70 inclusive. So really what you're doing here is you were given all these x's here, which you put into your function. This is our function here. So you put all these x's in here, into the x here, and you find your t of x here. And this is what you get to the nearest whole number in each case. So that will just take you a little bit of time just to do each one of those, but it's calculator work. After that then you need to plot the graph. It's our black graph here, p of x. Well, I've called it p of x for a different reason, but let's have a look at that later on. We have it's basically our black graph here, okay? So I plotted 0, 0, that's 0, 0 here. I've got 10, 8, so there's 10, 8 there. 20, 18, so there's 20, there's 18 there. 30, 29, there's 30, this is 29, and so on, and I've just connected them all up here. Okay? Now, let's have a look at the next part. A simpler function that could also be used to model the number of days needed to attain x words per minute is p of x, which is 1.5x. Now we have to draw on the diagram above the graph of p of x. So this is a straight line here, and I've actually, let me just redo that. This is actually going to be p of x here. This is the red line here, is actually p of x. So that's our straight line here. This here is actually our t of x. Okay, which is what we've just done here. So p of x is our straight line here. How did I do that? Well, we have p of x equal to 1.5x. P of x equal to 1.5x. Now that's a straight line. It's a linear graph. So what I'm going to do here is to pick 3 points, 3 x values, work out the y value and join them up. Really you only need 2 x values and y values, because you only need 2 points to draw a straight line, but it's always a good idea just to draw to calculate a third one, just to be sure that you haven't made a mistake somewhere. So I've calculated 3 points here for p of x. Now I've calculated 0, x is equal to 0, and found y is equal to 0. So 1.5 times 0 is 0. I've used x is equal to 30, which is here. 30, that's when I put that in, 1.5 times 30 is 45. I've also picked this one here at 70, at the other end of the graph. So x is equal to 70, so 1.5 times 70 will give me 105. And I've drawn those 3 points here, here, and connected them up. Now when you're doing this, use a ruler. I've done this freehand, so it's a little bit shaky here, but use a ruler, it'll be a lot more accurate. So we have our 2 curves here. We have our t of x, our original function, and we have this new function p of x here. Okay, so let's look at part E then. In part E, we're told that h of x is equal to p of x minus t of x. So it's a new function h of x now that we're going to look at. Use your graph above to estimate the solution to h of x equal to 0. So we're going to have h of x equal to 0, which means 0 is equal to p of x minus t of x. So if I bring t of x over here, it would just mean then that t of x is equal to p of x. This is really what we want to solve here. This part here. This is what, because this is what we want to solve, but I've just brought the t of x over here. So we want to know where is t of x equal to p of x on the graph. Use your graph, and I've done that here. Where it's actually equal here, but it's also equal up here. This is where the two graphs meet. So if you follow the green line down, you get roughly 62, somewhere around 62. Again, use a ruler here just to be a little bit more accurate, but I'm not too far off here. I'm looking at 62 anyway. So our answer here in this particular case is I'm going to say approximately 62. Okay, so let me just write that in first. So my answer here is approximately 62, and that's words per minute as well. Okay, so let's have a look at 3 then, or sorry, part 2 here. Use calculus to find the maximum value of h of x. The maximum value of h of x between 0 and 70. Well, if we look at our h of x function again, h of x is actually going to be 1.5. Well, let's just start a little bit. We'll just go back one step. H of x is equal to p of x minus t of x. H of x is equal to p of x minus t of x. Now, our p of x was 1.5x. That was what p of x, our p of x function was. Our t of x now was minus 62.5 times the log of 1 minus x over 80. So let's just simplify this. So it's p of x minus t of x. This is p of x, this is our t of x, and we've subtracted them. So we got 1.5x here, minus minus here is plus 62.5, and then we have the log of 1 minus x over 80, 1 minus x over 80, and that's it. Now, what we have to do, this is our h of x. We want to find the maximum value of this function here. So, and they're actually telling us to use calculus here. So we've got to find the derivative of this function and then let it equal to 0. Because minimum and maximum part of the function will be where the tangent is equal to 0. So we've got to, has a slope of equal to 0, I should say. So we've got to differentiate this, which will give us our slope, let it equal to 0. So if we differentiate 1.5x, we get 1.5. Differentiate this part here now, that's going to be 62.5. Now, if you differentiate the log of x, if you differentiate the log of x, so if we differentiate the log of x with respect to x, we get 1 over x. So this is our basic rule here. Now, if we differentiate the log of all of this, which is not an x, our answer will be 1 over 1 minus x over 80. But because it's not an x, it's a function of x, we must use the chain rule, so we must differentiate what's inside the bracket as well. Now, if we differentiate 1, we'll get 0. If you differentiate, we want to differentiate minus x over 80 with respect to x. This is what we want to do. Let me just separate that out a little bit. So this is what we want to do here. Now, minus x over 80, another way of writing that is just minus 1 over 80 times x. So if we differentiate a constant times x, we'll get the constant. So our answer here will be minus 1 over 80. So for example, if you differentiate 3x, your answer will be 3. You differentiate 5x, you'll get 5. So if you differentiate minus 180 times x, your answer will be minus 1 over 80. So anyway, this is what we get when we differentiated our h of x. So let's just simplify this a little bit. Well, our 1.5, we'll just leave that as it is. Now if you just think about this, we've got a plus here times a plus here, this is a positive fraction, times a negative here. So our answer here will be negative. Now we've got three fractions multiplied, so we're going to multiply the top by the top by the top. So 62.5 times 1 is 62.5. Let's multiply 1 by the bottom by the 80 here. So it's 1 times this is just going to be 1 minus x over 80. So you've got to multiply this 1 minus x over 80 by 80. So multiply 80 by 1, you'll get 80. Multiply x over 80 by 80, you'll get x. So we're down to this function here. So this is our differentiated function. Now we have to let this equal to 0 in order to maximize our function. So we're going to take 1.5 minus 62.5 over 80 minus x, and we're going to let that equal to 0, and we're going to solve this. So first of all, let's bring the 1.5 over, so we get 62.5 over 80 minus x is equal to minus 1.5. We can change this, so we can multiply across by minus 1, so that'll give us two positives here. I'll just do it up here. And then I'm going to multiply across by 80 minus x. So on the top we'll get 62.5, and across here we will get 120. 1.5 times 80 is 120. 1.5 times minus x, minus 1.5x. Subtract 120 from both sides, and that will give me minus 1.5x on this side. And on this side here we'll end up with minus 57.5. And finally here we're just going to divide across by 1.5, and that will give me 38 and a third. Okay, now we weren't actually asked to find x, we were asked to maximize, what was the actual question? Use calculus to find the maximum value of h of x. So it's h of x we actually need to find. So what we got to do is put this x back into h of x function. So remember, h of x is equal to 1.5x plus 62.5 times the log of 1 minus x over 80, I think it was, x over 80, yeah, x over 80. This is what we got to put it into. So we want h of 38 and a third. So that'll be 1.5 times 38 and a third plus 62.5 times the log 1 minus 38 and a third over 80. Now look, you can work this out individually, work this bit out, work this bit here out, and then add them, and your final answer will be 16.73. Now, were we asked to find out, let me just see, give your answer correct to the nearest whole number. So we got to give our answer to the nearest whole number. So that implies our answer here, if you like, our answer here will be, the nearest whole number will be 17 days. 17 days. That's our final answer there. Okay, so that's it for question 7.